Welcome everyone. I'm here with two people I love very much, Mr. Hardin, my dad, and Mr. Sheahan, a very good friend of mine, and we have a very special build today. We are building a Draisine.
You look very stylish.
Well, what do we have here?
We have the Chinese rapper, Ni Hao Chi Chao.
And are you going to do a rap for us then?
Yeah, Ni Hao Mi Chao. What Chao? Bars. That was wrong.
Today we are building a Draisine. A Draisine is a historical bicycle, an early bicycle in the evolution of bicycles that didn't have pedals. So we've got a little example of one here where this is a little kid's bike to help them teach how to balance, but it does not have pedals. But we want to build a full-scale version of this. And as we're designing this, really we want to think about the evolution of design, how one design leads to the innovations of the next design. So as we were preparing for this build, we started with our initial design. You can see it's got some 2x4s here, and we've attached some handlebars to it. And we are trying to, what we're going to do, we learned some valuable lessons from this, and we're going to do some designing to figure out what we are going to design next, because there were some fatal flaws in this, and it's not working quite how we want, but we know we can improve on this design. Do you want to tell us a little bit more about the Draisine and the history of the bicycle for a second?
Sure. The Draisine came about because there was a famine among horses, and horses died off by the thousands. So people needed a way to get around faster than walking. And this German count came up with the idea of attaching wagon wheels to a spar and walking along. And it was called the hobby horse, or the gentleman's dandy. He named it after himself, Count Draisine. Fasten these two together and drilled a hole that was the diameter of this top tube, and just stuff it in there. We put a bolt through it to secure it so it's not going to rotate, it's not going to come out. But what we found is that we couldn't spread these wide enough back here to accommodate the rear axle, because this material is so stiff. So we thought, we don't need 2x4 material for the strength of material, because we got buku strength there. Let's go to thinner material. So if we go with thinner material, we don't have enough meat here to make it strong enough to be safe.
Okay. I'm trying to still think about what I should do as far as getting the wheels to move, but pretty much you're gonna have a seat in the middle where it's gonna sit at. I was thinking like in a way to where we have a chain that's connected to both the front and back wheel, and we just implement some pedals that don't go in a spinning rotation. We have the pedals is connected to the chain in some sort of way to where it'll be able to force the chain to start rotating, and it'll have these two wheels start rotating as well. And as you're riding the bike, you just have to push your legs forward the whole time, and you'll be able to go.
Those are called treadles.
Treadle? That's
Treadles, instead of going in circles, it just goes back and forth like this.
Cool. This is the engineering drawing I came up with. This is the top view here. So these represent the 1x4s, and the dashed lines, those are called hidden lines, which means they're lines that are inside of there, but you can't see them from this view. Usually when you have hidden lines, you can see them as regular lines in the next view over. So if we're looking at the top view, we've got our 1x4s, we've got our 2x4s here that kind of separate out our frame to the width we need, and then we'll set whatever this width is to be the width of our wheel. So we'll either 2 or 3, or maybe we'll need to shim those down or shim them up, either way.
Piece, and now we're going to cut the slot for the dropout.
This is the piece of metal that we were just drilling through. We're going to have to file off some extra bits off the end, because the metal piece that had some extra bits on it right here is getting filed by DeAndre.
Damn.
So right now they are drilling the hole for the bike seat wedge.
We're drilling a hole to the seat post.
Material closer to you.
Reverse.
Putting the seats on the bike.
Piece by piece.
Important process.
We're here live with Eric Johnson at MC2 STEM doing the Bike of Evolution project.
1 to 10, how much fun are you having right now?
Right now, solid 10.
Alright, what do you think about the evolution of bicycles?
Yes. Oh, wrong answer. I think the bicycle was a phenomenal development in human locomotion. And it's still my preferred way of traveling.
So what do you think evolution means?
Anything can evolve. Your ideas can evolve. You can evolve personally. Obviously there's evolution with biological creatures as they go from generation to generation. So the word evolution really just means a lot, and it's hard to kind of nail down. So in engineering, we're really studying kind of the evolution of our ideas and the evolution of design. We're really starting to study the iterative design process so that we can make a final product of something that works well and is easy to make and get proud of.
What do you think evolution means to you?
Change in response to external stimulus.
Okay then.
Survival of the fittest.
So what do you think evolution means?
I think evolution means changing based on the environment over time to suit your needs better so you can live longer.
So what does evolution mean to you?
To me, evolution is transformation through time.